Okay, so this problem says a rocket sled accelerates at a rate of 49 meters per second square. So you want to, when you look at these numbers, you want to get used to seeing how many G's is that? And divided by 10. So that's 50 divided by 10, that's 5 G's. So this rocket is applying a force of 5 times the weight of the sled on the, okay? You want this thing. Its passenger has a mass of 75 kgs. Calculate the horizontal component of the force the seat exerts against the body. Compare this with his weight using a ratio. Okay. All right. So I guess I'll make a simple drawing here. There's the seat, there's the person, and this whole thing is accelerating at 49 meters per second square. Okay, so the seat, what we are interested in is, so the question is, calculate the horizontal component of the force the seat exerts against his body. So what we are interested in is the motion of this guy. And Newton's second law can be applied to any object. So we'll apply it to this object. And there's a couple of things the seat has to do. The seat has to give him this acceleration, but also see gravity is trying to pull him down, so the seat has got to hold him up. It's got to prevent him from going to the center of the earth. But we won't be concerned with that normal force right now. We are just interested in the horizontal force. Okay? All right. So the force that the seat exerts, again, just for reference, here's our axis. And so the x component of the force that the seat exerts on the person is his mass times acceleration, 75 kgs times, my friend, $4. Okay, thank you. And that is 5 mg. Okay, so the force that the seat, horizontal force that the seat exerts on the person is 5 mg. Okay, now just to this, the problem doesn't ask you this, but so there's the x component of the force, and the y component of the force that the seat exerts must be equal to mg. So the net force that the seat exerts on him is 5 mg. Yeah, open it. Yeah, I want you to eat it. Just don't be noisy. So, okay. So there's the net force that the seat exerts. Okay. All right. Calculate the direction and magnitude. The total forces. Oh, we do need that. All right. So, the magnitude of the force would be 5 mg square plus mg square. Okay. And here is mg if you want it. Okay, but anyway, we'll calculate it like this. So this will be, that's 25 plus 6 square root of 26 times mg. So there's the magnitude of the force that the seat is exerting on the person. Okay. And we'll figure out the direction. Okay. So let's figure out the direction of this force. Okay, so this angle is 11.3 degrees. Okay. And that makes sense. The force has a large x component and 1/5 the y component. The y component is 1/5 the x component. So it's a mostly horizontal force. Okay. In the limit, this is infinite compared to that, the force will be horizontal. Okay. And well, that's just stating the obvious. All right. So that finishes that problem.